For our feedback project, we utilized an ATX power supply found in modern computers. It's capable of outputting 12 volts, 3.3 volts, or 5.5 volts. In terms of the current utilized, we actually ended up using about 3 amps based on the resistance of our coil. For the controller, we used an Arduino Uno R3, and next to it, on the half-size breadboard, you can see the logic level MOSFET we used to control the 5.5 volt PWM signal and to control the 12 volt power coming from the power supply. For the coil, we opted to use our own custom coil, which was wrapped with 22 gauge wire. We used a 1/2-inch core that we had custom machined. And for the sensor, we opted to use an NPN phototransistor and a corresponding infrared T6 package LED. For the overall structure, we went with a 16-gauge steel box tubing welded at that joint over seen to the top right. And seen here is the diode between the solenoid.
When we began our trials to test our solenoid, we first used a cylindrical slab of metal. The metal proved to be pretty heavy. It was actually too heavy to be levitated by our solenoid, so we added a magnet on top of it in order to give it a little bit of extra pull and effectively make it lighter. This object was relatively unstable. We were only able to get it to levitate for about 2 minutes. After levitating for about a minute, the object would start to oscillate. This oscillation would rapidly become more unsteady, and the object would end up falling out of the set point. Eventually, we wound up using this much lighter screw. The screw proved to be much more stable when we were levitating it. In our latest trial, we were able to get it to levitate for well over 30 minutes, and we believe that if we just left the system on, it would levitate practically indefinitely. We think that the reason it's much more stable is because, one, there's no extra magnet to interfere with the magnetic field of the Levitator solenoid, and two, because the object's center of gravity is higher than the geometric center. Here we're trying to induce instability in the system by adding a disturbance to see how the system would correct for it. It would take a while, but eventually it would return back to the object set point and levitate just as stably as when we put it there. Here we're cutting the power to the system to see how it falls.